What's up, everybody? And good morning, good afternoon, good evening, whenever you're looking at this. And let's continue working with inverse trig functions. Woohoo! All right, I'm getting out of here. Bye. Oh, by the way, after this lesson, probably Thursday or Friday, look for an informal vote, whether on Monday you'd like to have a video like I've been making, or if maybe at 1 o'clock, I know I said 1:30, but we could do 1 o'clock. 1 o'clock, would you like to do a live Zoom class instead of this pre-recorded video? I'll put that up and you could vote whether you'd like to do Zoom or just a video. All right, see ya. All right, so we're evaluating more inverse trig functions today. So what I did was I pre-wrote all of the restricted domains of the capital trig functions, capital sine, capital cosine, and tangent. Where did I get these restrictions from? I got them from, hold on one second here, let me go to a different share. I got them from Miss Shoemaker's awesome sheet where she did all the trig restrictions. Keep this in front of you. I mean, hey, one of the benefits of being at home is that you can just have this in front of you at all times, okay? What I did was I just put it right here. And instead of shading, I just put X's. So the restrictions on the domain of sine are between negative pi over 2 and pi over 2. Around a unit circle, that's quadrants 1 and 4. All right, how do we find the inverse of sine? I know that you know what's already called the arc sine, but how do you find an inverse in general? Inverse in general is flipping x and y around. So the inverse would be x equals the sine of y. But then, as Mrs. Middleton showed you, you need to solve for y. And how do you solve for y? You take the inverse on both sides. And so the inverse on both sides is going to be y equals the inverse sine of x, or as it's also referred, y equals the arc sine of x. In future problems, whether you see sine -1 or arc sine, they mean the same thing. But you flip the values of x and y around. So what happens to the domain and range? They get flipped around as well. And what I did was I just, write the eraser here, sorry. I wrote in blue right here. So the domain is now going to be between -1 and +1 inclusive. And my range is going to be going from negative pi over 2 to pi over 2. This is going to come in handy. By the way, I'm not going to focus on the right side of this, the domains and the ranges of the right side right now. I just wanted to point them out. We might even return to this later. No, we might. We are going to return to these domains and ranges later when we graph the inverse trig functions in a few lessons. But for right now, I just want us to focus on the left column here and the restricted domains where these x's are. That's what we're going to be using today. All right, but we will be finding the inverse trig functions. I know it sounds so confusing right now, but I'll explain that right now, okay? So number 1 says we need to evaluate the arc cosine or the inverse cosine of √3/2. What does that mean to you? Well, remember, whenever you're finding the inverse, you flipped the x and y around. So this is actually the answer to the trig function. And what we're doing is we're finding the angle that produces that answer. So I'll even write a little note here. Think, basically, I'm trying to find out the cosine of what angle would produce an answer of √3/2. And notice I wrote capital C because it's a capital arc cosine. All right, so just as a quick review right here, where is cosine positive? I could think right now, all right, well, where's cosine positive? All students take calculus. Cosine's positive in 1 and 4. That's all fine and good, but what is the restricted domain of cosine? Cosine, the restricted domain, so that it's a 1-to-1 function, is quadrants 1 and 2. Uh-oh. So that eliminates quadrant 4 right off the bizat. So we're only left with quadrant 1. So what you can do is you can draw a triangle in quadrant 1. I know that cosine is adjacent over hypotenuse. So the adjacent side is √3. Hypotenuse is 2, which means this side has to be 1. What angle goes across from the 1? It's a 30-degree angle. Okay, great. So my angle, theta, would be 30 degrees. However, I will specify on any kind of assessment whether I want the angle in degrees or radians. How do you write 30 degrees as a radian? Well, keep in mind, isn't 30 degrees just 180 divided by 6? Yeah. Well, what's 180? 180 is pi over 6. I know that's my little dumb way to think about it, but there are my angles right there. So my answer to number 1 is either 30 degrees or pi over 6. That's how it's done, yo. All right, the arc cotangent of -1. Again, trying to find the angle where the cotangent of theta equals -1. That's what we're trying to find. All right, so where are the restrictions on cotangent? Cotangent, oh, it's right here, quadrants 1 and 2 again. And so right off the bat, I got all students take calculus. I know that cotangent is negative in quadrants. I know that cotangent's positive in 1 and 3, all and tangents. So quadrants 2 and 4 is where it is negative, but the only one of those that is within the domain of the restricted domain, sorry, I could speak, is quadrant 2. Why? It's right here. Let me use my cursor. It's right there. That's the only quadrant where it's negative within the restricted domain. So I could draw myself a triangle in quadrant 2, and cotangent is x over y, or adjacent over opposite. So that's -1 over 1. What angle produces that? 45. And what's 45 degrees up from 180? That's 135 degrees. So theta is equal to 135 degrees, which is also equal to 3 times pi over 4. Pi over 4 is 45 degrees. 45 times 3 is 135. There we go. All right. We're going to start to fly through this right now. The arc sine. And I'm going to write 2 over 1. I always like to write my trig functions as fractions, even if it's not written right there. So I need to figure out the sine of what angle would produce -2 over 1. Ooh, all right, well, let's think here. Where is sine negative? Sine is negative in 2 and 4. Let's go up to the restrictions for sine. Sine needs to be in quadrants 1 or 4. So ding, 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 ding. I think we found our quadrant right there. It's got to be quadrant 4. Be careful with this. I know it's -2 over 1, but what I do is, first off, sine is what? Opposite over hypotenuse? Is that even possible? Wait a second. Time out. Time out. Can the hypotenuse not be the largest side? Isn't a rule of a triangle, a right triangle, that the hypotenuse is the largest side of the triangle? So yeah, man. So in this case, I might just write this, NFMK. Not fooling me, Collodi. There is no solution to this one. All right, the hypotenuse cannot be smaller than one of the sides of a right triangle. Okay, and so let's move on to the next one here. The sine of what angle will produce an answer of -1/2? Well, this is good. I think this is more respectable. Again, S and C. Can't be this one. It's got to be right there. It's exactly the same deal. It's a negative value for sine. Okay, now let me draw a triangle right here. Again, opposite over hypotenuse. The opposite side is 1, which is negative. The hypotenuse is 2, which means this is √3. And what goes across from the 1? The 30-degree angle, which means this is 330 degrees. There's my answer. So theta either equals 330, or as a radian, that would be 11 times 30 degrees. 11 times pi over 6. Pi over 6 is 30 degrees. 11 times that is 330 degrees. Boom. Here we go. All right. So that's how this works out right here. All right. There are other examples. Cosine. So I'm trying to find, equals theta. Sometimes you get really mixed up if you don't see arc cosine. See cos -1. Don't be fooled. This still means I'm trying to find the cosine of what angle produces an answer of 1. I'm going to write 1 over 1. Where's cosine positive? Cosine is positive in 1 and 4. But the restrictions of cosine are 1 and 2. So it has to be quadrant 1. Okay, so cosine is opposite over adjacent. Now, I jumped the gun here. Can the adjacent side and the hypotenuse both be 1 when you draw a triangle? No, it cannot be. So let me erase this. I believe we have ourselves a special angle. When is cosine equal to 1? Remember, cosine also equals x over r. I think that's what we're going to be doing here. Unit circle time. When does the x value equal 1? And when does the r value also equal 1? Think of a unit circle this time. All right, the radius is 1. And I don't know if Mrs. Middleton ever taught you this, but this is a unit circle. I'm sure she did. So wait, the x is 1 here, and the y is 1 there. And what angle is this right there? That's 0 degrees. So theta either equals 0 degrees or 0 radians. That's the only place where it's going to equal, where cosine will equal 1. Arc sine. So the sine of theta is going to equal 0. 0. All right. So I think this is another unit circle problem right here. Oh boy. Wait a second. Sine, I'm going to write 0 over 1. Sine is y over r. Wait a second. Isn't this the same darn thing? This is the coordinate 1, 0. And I know that the radius equals 1 here. Wouldn't sine be 0 over 1 at this particular angle? What angle is that? That's 0 degrees again. 0 degrees or 0 radians. So theta once again equals 0 degrees or 0 radians. Hot dog, as Mickey Mouse would say. Hot dog. All right. So where does the sine of theta equal negative root 2 over 2? All right. All students take calculus once again. Sine is negative in quadrants 3 and 4. But which of those quadrants satisfies sine's restrictions? The restricted sine's only in quadrants 1 and 4. So right then and there, this guy's out of there. You're out of there. Quadrant 4. Boom shakalaka. All right. Now, I know that sine is opposite over hypotenuse, but if I unrationalize this, I know if that's a word. If I unrationalize that, how do I unrationalize it? By multiplying by root 2 and root 2. And I'll end up, just bear with me here, negative 1 over root 2. Yes, if you go through the algebra, that's what you'll get. So that's the opposite sine over the hypotenuse. You shouldn't have circled that because that's not the answer. Okay. So that means my opposite side here is negative 1, and this is root 2, which means, oh, it's a 45, 45, 90-degree triangle. And so that means this is 315. And so my answer for theta, remember, this is theta right here, is either 315 degrees or 7 pi over 4. Good. Last but not least, where would the secant of theta equal 2 over 1? Okay. Where is secant positive? Secant is positive where cosine is positive. All students take calculus. All right, so where's cosine positive? Cosine is positive in 1 and 4. Remember, secant and cosine are reciprocals. So these two are automatically out. But what are the restrictions of secant? If you need to go up, scroll up. Use the sheets. Restrictions of secant are either quadrants 1 or 2, not including pi over 2. All right, so this guy's gone and it's quadrant 1. So I could draw myself a triangle, quadrant 1. Secant is hypotenuse over adjacent. So hypotenuse is 2, adjacent is 1. That means this is the root 3, and that means this is the 60 that goes across from the root 3. And bada bing, I've got my answer. 60 degrees is also 180 divided by 3, pi over 3. I hope this has helped. Let's get to some composite functions right now. Okay. Oh boy, oh boy. Functions within a function. It's like the Inception movie of trig functions. If you've ever seen Inception, oh, I get lost after like an hour and a half. All right. Always work your way from the inside out. From the inside out. And always be mindful of the domain restrictions. This is absolutely huge. So I'm going to start with the inner function here. Basically, the tangent, that's a capital T, of what angle would produce root 3. All right, so if I work that through right here, let me just do some quick work. That's going to be quadrant 1. So root 3 over 1 is opposite over adjacent, so root 3 over 1, so that's 60 degrees. Oh my gosh, that is the worst 60 degrees I've ever drawn. Let me get rid of this here. Let me do it again. Root 3 over 1, opposite over adjacent, that's 60 degrees right there. So basically, I'm asking us to find the sine of 60 degrees, because that's the angle that produces that answer. Now, the sine of 60 degrees, which I just wrote right there, this is 60 degrees. What's the sine of this triangle right here? Opposite over hypotenuse, root 3 over 2. Really wasn't so bad, was it? First, you get the angle on the inner function here, in this particular problem, not every problem, and then you find the outer function of that particular angle. All right, let's see if this second problem, number 10, is the same type of deal right here. So we're trying to find out where the secant of theta will equal -2 over 1. We've already dealt with where is secant negative. Where is secant negative in quadrants 2 and 3? And what's the only one satisfies that? I'm cutting to the chase here. You can pause and scroll back up at any time if you want to. That's quadrant 2. All right, and so secant is hypotenuse over adjacent. Keep in mind, the hypotenuse can never, ever be negative. Even though there's a negative next to that 2, it's really the fraction that is negative. Either one of those numbers could be the negative number. In this case, it's the 1. And so this is the root 3. This is the 60 here. And so what's a 60-degree angle in root 2? What's 60 degrees up from 180? It's 120. So this is the angle that I'm trying to find right there. So I'm trying to find basically the sine of 120 degrees. Okay. And so the sine, and that's a capital sign right there. Can I find the sine of 120 degrees, the restricted sine of 120 degrees? Let's find out. 120 degrees is quadrant 2, obviously. Can I do a restricted sine problem of 120 degrees? The answer is, oh no, I cannot. So then what's the answer here to a restricted sine of 120 degrees? It is no solution. Just for kicks and giggles. Could I have done the lowercase sine of 120 degrees? Absolutely. Lowercase sine of 120 degrees would be y over r, or opposite over hypotenuse, root 3 over 2. Keep this in mind right here, everybody. That's a huge difference. Draw arrows in both directions. Okay, so I'll write that. Be careful of domain restrictions. Okay, next one. Let's do this right here. Oh man, I think we probably learned with Mrs. Middleton. Anytime you have something combined with its inverse, you should just get this answer. The answer, watch, if you didn't know that, if you don't know, now you know. The answer should be negative root 3. Over here, inverse cotangent and cotangent, the answer should be negative pi over 4. Why do I say should be? It should be as long as you are within the domain restrictions, huh? You might encounter a situation where you are not within the domain restrictions of the answer right here. So basically, I'm going to say here the cotangent of what angle produces negative root 3 over 1. Okay, where is tangent and cotangent negative? Tangent and cotangent are negative in quadrants 2 and 4. And what are the domain restrictions of cotangent? Cotangent could be in 1 and 2. So what's our winner here? Quadrant 2, cotangent is negative in 2. So I'm going to draw a triangle in 2. And cotangent is adjacent over opposite. So adjacent is negative root 3. This is 1. Across from the 1 is always the 30. What's 30 degrees up from 180? 150. That's the ugliest 150 I ever drew, but what's the cotangent of 150 degrees? Notice it's lowercase cotangent here. By the way, this is 2 right there. The cotangent is negative root 3 over 1. So guess what? We fell within the domain restrictions. And I'm just going to do this right here. We got back what we started with. Basically, these two trig functions just canceled one another out. And because I was within the domain restrictions, I just got back what I started with. Let's see if that works out here. The cotangent of negative pi over 4, notice the inner function is lowercase. Okay, so the cotangent of negative pi over 4 is like saying the cotangent of negative 45 degrees. Negative 45 degrees is down here. So that's a 1, that's a negative 1, that's a root 2. And cotangent, well, what angle produces this here? This is 45 degrees right there. Okay, what angle is that? That's, let's see here. The cotangent is adjacent over opposite. So that's like saying the cotangent, the arc cotangent, I should say, of negative 1. This equals negative 1 right here. Put that right there. So now I'm going to ask myself this question. The cotangent of what angle produces an answer of negative 1 over 1? Where is cotangent negative? The capital cotangent right there. When is that possible? All right, well, let's see here. Let's see. All right. Let's find this out. Okay, let's see. Can this be possible? Cotangent is negative 1 over 1. Sorry, I got distracted. My kid just kind of walked down the steps. There was a momentary pause right there. All right, so where is this possible? All students take calculus again. Where is cotangent and tangent negative? Quadrants 2 and 4. Okay, and so where does this occur? Right there, it's quadrant 2. Remember, the restricted domain is right there. And so what will I get as an answer? The restricted answer is actually now in quadrant 2. Negative 1 over 1. So it's 45 degrees in quadrant 2. Weird, man. What's 45 degrees up from 180? 135. So my answer for this is theta is this quadrant 2 45-degree angle, which is 135 degrees, or 3 times 45, 3 times pi over 4. So notice I did not get back what I started with. I did not get back what I started with. I know it seemed a little convoluted because I paused for a moment, but please pause and review number 12. That's a tricky one potentially. All right, for the last 4 examples, I want you to get out your calculator. How do you find inverse trig functions on your calculator? You just type them in. I'm actually going to save 13 for last. So for number 14, I'm going to hit second. I'm going to hit cosine, then 0.13. And let me go into my calculator right now to do that. First and foremost, you need to make sure that you are in radian mode. Go to your mode. Make sure you are in radian mode. If you're in degree mode, go over to radian. So I'm going to hit second. Cosine, that's the cos negative 1 of 0.13. And I'll get my answer of 1.44. Done. So let's go to sheet. So theta, 1.44. Yay! And that's, by the way, 1.44 radians. The arc cotangent of 2.6. All right, so let me go to my calculator. And let's get to it. Second tangent. Oh, wait, time out. Let me go back to the sheet. Oh, yeah, I forgot. Can't just type that in, right? So this is basically saying the arc tangent of 1 over 2.6. Okay, you went over this with Mrs. Middleton. Take a moment to let that set in. Remember, cotangent is adjacent over opposite. Tangent is opposite over adjacent. And so when you do that, now I could do the tan negative 1 of 1 over 0.6. Does that ring any bells? Hopefully it does. So now I need to go to my calculator. And I'm going to hit second tangent, and then 1 divided by 2.6. Hit enter. And I get 0.3672. What should you round that to, Mr. Cody? Well, just read the directions when you go through. I'll just round it to 0.37 since that's what we did before. So this equals 0.37 radians. The arc secant of -6. I guess that would mean that it's the arc cosine of 1 over -6. You agree? And so then I'm going to do the second cosine of -1 over 6. That's what I'm putting into my calculator. That's my calculator ready form. So second cosine 1 divided by. No, I could just do 1 divided by -6, or I could do -1 divided by 6. Doesn't matter. Either way, I'm going to get 1.7 through 1.74. Okay. And 1.74. I made a note here. What if I'm trying to find the value of something negative like I did in number 16? You can plug in all values, even negative values, in your calculator for every single function except cotangent, because it's the only function where the solution doesn't match up with those domain restriction quadrants. So if I ask you to find the inverse cotangent of something negative, you're going to plug in the second tangent, or the tan -1, of the positive value. And then I want you to think about this right here. The restrictions on cotangent are that they're in this quadrant and this quadrant. So the answer is just whatever answer it is right there. Quadrant 1 is just quadrant 1. Remember, this is pi right here. So to find the answer in quadrant 2, I need to do pi minus whatever that answer is. So what does that mean? That means the tangent, this is going to do the tangent of -1 over 7. Tan -1 of -1 over 7. So what I'm going to do is I'm going to do the inverse tangent. And by the way, this should be a capital T. I apologize. This should be a capital T. I apologize. Of +1 over 7. This only applies for cotangent. So I'm going to go and I am going to hit second tan of +1 divided by 7. And I'll get 0.141. But it's negative. Where is cotangent negative? In quadrant 2. So I need to do second pi minus, and check this out, I could just hit second answer, and I don't have to worry about rounding it off. Hit enter, and I get 2.999. All right, so it's, yeah, so I'm just going to write 3 then. So it's, which equals 2.999, which equals 3. Again, pause the video, rewind, do whatever you need to do. A little bit of a long video. I hope this helped. Email, message if you got questions. Bye.